Hello everyone, hope you're doing well. My name is Mahmoud Kiyomizu-dera and welcome to the new chapter of control. Actually, this is not a new chapter, this is going to be introductory chapter. So I had an amazing trip to Japan, and in that amazing trip, I found out lots of cool thing about that. I thought with myself, so what would be the best sort of introductory part for the control system, because I had a couple of videos related to that. Again, they were random, but at this point I would like to make them categorized, make them sorted out, and make sure that you completely understand it from the beginning to the end. So I thought it would be better to start this chapter by just talking about a very interesting story about Japan and how they actually became Japan, and what is the control aspect, the control part of that actually, which plays a very important role in not only in that country, but also in other countries, in other kind of system, and very important section of our day-to-day lives. So I thought it would be better to start with that. Without further ado, let's talk about it. So as I mentioned, I would like to talk about the control, but not in the normal way, in the boring way that you have to some kind of deal with numbers, with everything. No, not right now. At this point, I would like to talk about it with the story of my trip to Japan, based on the thing that I saw, based on the places that I visit, and I would like to connect those concepts to the control, or most specifically, I would like to talk about the feedback control and the hidden tech running Japan. So at the very beginning of the point, when you go to this city or any other kind of big cities, for example, New York or Los Angeles or any other kind of cities, the very first thing that would catch your eye would be about how flawlessly it actually works. How everything works perfectly. Why? The why is hidden beneath three important points: precision, reliability, and automation. I mean, talk about the crosswalk. As you can see over here in this image, we do have some kind of big crosswalks. I mean, some kind of important one actually in Japan and in all around the world is about the Shibuya crosswalk. So you have lots and lots of people that are some kind of moving around without any kind of causing accident or issue. About the vending machines, that I really like it because vending machines also plays a very important role in Japan itself. And also about the elevators. The elevators, they do have some kind of skyscrapers. They do have different kind of tall buildings, and most of the time you have to use the elevator, not just using the stairs. So we would like to see that what's going on. One of the first thing that I would like to start is about the bullet train. Actually, probably you saw some kind of videos related to that, but what is the reason that actually it works flawlessly? It is fast, it is precise, you're not going to have any kind of accident. So these kind of trains, as some kind of fun factor, can move up to 320 kilometers per hour, and they're perfectly on time. I mean, I was in it and everything was flawless, everything was smooth, but how actually they're going to work? So the magic isn't just about the manual driving, right? It's continuously measuring the reality and auto-correcting the difference. What does that mean? It means that right now, when you're talking about the bullet train, when you're talking about the distance, when you're talking about the speed, everything is related to control, not only just normal control. It's a closed loop feedback control. It means that everything is automated. The human, yes, it just goes there as the operator, but it cannot control anything. Imagine that you face some kind of issue and some kind of maybe the human cannot act fast. So at this point, you need a closed loop controller. You need the automation to make sure that your train can go around 320 kilometers per hour. By the way, that was a very, very speed. And also it has the perfection on almost everything. Another thing that caught my eye was about the robotics, because as you all know, the robotics and some kind of the AI and everything is try to devour our day-to-day life. But important thing is that how actually they work. I mean, they are going to see what's going on, for example, in your hand in a perfect angle, and the vision which is going to act as in feedback and all of the forces, how actually they are going to work. While they do have something we call as MIMO, which means that multiple input control, and simultaneously it has some kind of invisible loops calculating and real-time physics. So again, everything is happening using the closed control loop. Another thing which is, I really like it, was about the vending machines. Another part of Japan was about the vending machines, which I really enjoyed it. Every time when we were out, we were trying to have some kind of, for example, drinks or maybe at some point foods. We were using some kind of vending machines because yes, they had some kind of grocery stores, but it doesn't necessarily mean that it was there all the time. So we use this guys. So how actually they work? So the thing is just simple, just like the way that we know about the vending machines. You are going to some kind of product, whatever is that, then you have to some kind of coins inside of that. And when you have the coin in it, you do have the sensor. And this coin, obviously, for example, something is 1,000 yen. So you have to make sure, or actually machine have to make sure that you just pass 1,000 yen. Rather than that, it would make any sense, right? Well, for instance, you are going to have a drink and it's around 1,000 yen. And after that, you pay 800 yen and machine some kind of to have misinterpretation and give you your drink. So obviously it doesn't make any sense. It doesn't have any kind of profit. So it is very important that you have the right sensor that's going to verify the amounts. Then about the selection, I mean, you pass the 1,000 yen, so you have to some kind of pass something. But the thing is, it's not only about your selection. Actually, the vending machine should also check the inventory to see that, does it have that specific type of drink you want? Then we do have the motor itself. It's a move arm. It means that at this point, that kind of robotic part is going to go to the inventory and is going to grab the thing that you want, and finally is going to drop the item that you have it over here, or at some point I can say that you use some at this part, and after that you just grab it. So again, everything that's some kind of, it's because of the miracle of automation. Again, it's not that kind of a big deal. It's a tiny control engineer. It's just a metal box. But important thing is it constantly going to verify reality against the user command itself. Another important one is about the elevator. So obviously you use some kind of the elevator in our country, in some kind of your country. But one important thing about the elevator is that they have to have being smooth. It means that at the beginning of the point, we wouldn't like to be some kind of like step. I mean, talking about some kind of speed over here. Obviously, we need those guys to be smooth. Then they are going to increase their speed. And finally, we do have also smooth end. So at this point, we are also talking about the controller. So we do have the smooth acceleration. We do have the perfect stopping. Rather than that, imagine that your speed is going to bump it just one, and after that, you're just going to feel nauseous. You're going to vomit. And it's not very, very good. Also, it's very important because we do have some kind of wall buildings and a skyscraper in Japan or any other kind of. It's important that it should be smooth and also it should be fast. For instance, you have 50 levels and you would like to reach from the first one to the 50. If it's not fast, if it's not smooth, either you're not going to reach to the level that you want, or you're going to feel nauseous. And one of the very, very thing was about some kind of Shibuya. So the Shibuya crosswalk is the biggest crosswalk around the world, and every day we have thousands and thousands of people that are going to pass this crosswalk. I mean, some kind of touristic area, to be honest. And at some point, you do have kind of different sensors over here in this some kind of crosswalks. So what these sensors actually do, these sensors are going to detect the crowd volume, and based on the logic is going to give you some kind of adaptive timing. So the output is going to be the green wave, and finally, we do have the length reduced at some points because you do have massive number of people. So obviously, the green light should be a little bit more actually about the timing, and at some point, you don't have that many of people. So obviously, the green light should be a little bit less. This is going to be another perfect example of closed control systems. So what is happening? What is the universal engine? Again, we can some kind of use it in different kind of settings, in different kind of works, but they actually are going to follow a simple rule. First of all, they're going to measure on the thing that they actually there. For example, about the sensor part is going to measure the weight of the people. Obviously, based on that, it can decide that how many people are going to pass the crosswalk. Then it's going to compare it with the compare it with the actual some kind of settings that it's set based on the human sources. Then it's going to adjust on all of the thing based on the measurement, and they compare it. They're going to adjust the fact based on that, because if you guys remember about the closed loop control, you do have some kind of input. We call it as a set point. And after that, this set point is going to be compared with some kind of your measurement value or the feedback value all the time. And finally, we do have the repeat. All of this process is going to be repeat is going to reach to the factor that we want. So the core problem actually is happening around us is that the world is uncertain. It means that, for example, you do have some kind of wind, you do have some kind of weight changes and anything, but at the other hand, you need something to make sure that everything is going to be adjusted. So it means that you need a feedback control. That's why it is very important. I mean, next slide, we're going to talk about two different types of controllers. One is open loop and another one is closed loop, but that is the reason why we need feedback one more than the open loop one. I mean, going to increase the complexity and everything related to that. But at this point, we would like to know how precise we can be. So real systems are completely unpredictable. I cannot say are completely unpredictable, but unpredictable. Feedback removes the need to know everything in advance. I mean, don't have any feedback controller. You have to predict everything beforehand, and you have to consider all of the scenarios for your machine. Obviously, you cannot predict everything, especially when we are dealing with uncertainty every day about the renewable energies, about some kind of the wind speed, about anything. That's why you have the feedback control loop. So by constantly measuring and adapting to reality, we can make sure we just set it to the result that we want, and finally, we can have it. So this is the very important part. This is going to actually play a big role in the control section. We do have two different types of controllers. The very first one is the open loop controller. What does that mean? It means that you do have some kind of set points. You put a set point for yourself, and after that you have the controller, you have the actuator, I mean, some kind of the basic and the foundation of any controller system. And after that, your output is your temperature. Imagine that. But the issue over here is that you put the inputs as the number that you like, the temperature that you desired, and your machine is going to do something. But the problem is that your machine is completely blind. It's going to do something, and based on that, it's trying to say that, okay, hopefully it's going to work out. But when you are, as a human, you see that, okay, that's not the thing that you like. For example, you put it as a specific temperature, and then finally the room is getting hotter. So you say that, okay, I have to decrease it down. Actually, you are going to work as the closed loop controller. You are going to work as a feedback, but the machine itself doesn't have any kind of sense what's going on related to the outside world. So this is a very, very issue, and obviously you don't like that. When we are talking about the closed loop controller, when we are talking about the feedback controller, we say that we do have everything that we need. We do have the input set point, but at this part, other than just a controller and actuator itself, we do have the sensor and we do have the comparator. So what is happening? The sensor is going to sense the outside world and is going to give some eyes and ears to your specific, some kind of machine. Then this guy is going to be compared itself with what? With the input set point itself, because it would like to see that, okay, doing it right. How far am I some kind of, what is my distance from the current situation and the situation that it would like to reach? So we do have this part, and based on that, we can make sure that everything is going to be work seamlessly. We are going to be precisely on target, and we do have the constant real-time connection. Rather than that, we don't have any, if kind of disturbance happens, we cannot handle it in the open loop, and accuracy obviously is not that good, and adaptability is not that good either. So engineering in the model civilization is not just about the crosswalk, the vending machine, it's about the robot, it's about anything. When you're talking about aerospace, when you're talking about those kind of some kind of projects, obviously you have to make sure everything is happen flawlessly, rather than that everything is going to collapse. When you're talking about the healthcare, yes, these days we are going to use more and more of robotics, so it is very important that we do have the precise controller that can actually deal with the fact that we are going to save lives, right? So we cannot just say that, okay, doctors can do anything by themselves. These days we are going to use the robotics, but in the meantime, we have to make sure everything is happening precise. Everything should happen some kind of based on adaptability. Everything should happen seamlessly. And we are talking about the electrical vehicles, or we are talking about the autonomous. Like the Tesla one. So we have to make sure that everything is going to happen seamlessly based on the sensors that we do have it on the front side, on the windshield part, and we are getting some kind of feedback, and based on that, the Tesla is going to adapt itself. And finally, we are talking about the energy, about the supply and demand balancing, which is to play a very, very role in our day-to-day life, especially about electrical engineering. So about the engineering skill tree, first of all, we have to understand. We have to decode the system around ourselves to see what's going on. Then we have to model that, translate the physical reality into mathematical equations, which we are going to see it in the future. We have to analyze it. We have to predict the system behavior before actually it's built. Then we have to design. We have to have some designing for ourselves based on the controller, based on everything that we have. And finally, we do have the implementation. Obviously, this fact, there's some kind of not going to be end at the implementation, because we know we do have some kind of repetition. We have to some kind of modify. We have to adjust everything. So that is a cool part. And finally, we are going to say to you that welcome to the club, because the story wasn't just about Japan. The story about a very, very course named Control Systems. And in this specific course, we are going to deal with everything from the understanding to some kind of mathematical thing, to some kind of designing, implementation, and obviously repetition. So let me just give you a very, very introduction about this one. And actually, I would be more than happy to have you guys by myself. So probably in the next couple of videos, and I'm trying to make them a little bit faster, because obviously in the past few days, I was in Japan. I was just enjoying. That's fascinating. It's once in a lifetime. But in the upcoming videos and in the upcoming days, I would like to some kind of more and more videos, especially about the control system. So far, we talked about the mathematics, we talked about the electrical circuit, but it is a very good point, because right now we do have enough knowledge about both of them to actually use them in the real time. So my name is Mahmoud Kiyosari. Thanks for watching this. Please don't forget to share and comment, and obviously put some kind of like over and subscription. I will be very, very. See you around. Take care.